So what does this mean? This means that if you are going to improve your cycle time for ST4 station, for 1 minute, you need a cycle time improvement. Do a method time study, cycle time study for this, and you need to identify that what are the ways to reduce the cycle time from 3 minutes to 2 minutes, And then another thing you need to do is for ST3, you need to identify cycle time improvement by reducing the cycle time from 2.5 to 2. So one thing which you can also do here is that if you could look, we have reduced 0.5 minutes here and we have reduced 1 minute here, that is in total 1.5 minutes in here. You can have an additional shared operator who can take a load of this, then go in here, support in here, come back again and work on that. Okay, so that will basically make this as 1.5. So what we will do, we will say that use 2 operators here on the ST4. Okay, and then you are supposed to use 2 operators in before also, because we reduced it from 5 to 2.5. So when I just reset and run this, so now we have 2 operators here, we have 2 operators here, we are getting 538, which is 26, and our bottleneck station is ST3. What we need to say is that whenever this is idle, ST4 is idle, my operator from ST4 should go and support for this additional 0.5 minutes onto the ST3. So when I just reset this and run it, I'm going to get my demand of 673 bottles per day with 33 pallets per day. Okay, this is how we debottleneck the systems. It's very effective to visualize using the simulation model, guys, right? By using the real-time statistics into the system, by visualizing the web, and there's a lot of stuff which is very advantageous to use simulation for your manufacturing industries to deal with all the issues you're facing, right? So the Random Industries is now able to create a targeted demand of 675 with what as recommendations. So for getting its demand per day, that is 450 bottles, they need to use 2 operators here. So I'll just place 2 operators for the time being, so to have a visualization. When they use 2 operators here, we are able to meet our demand, which is 450. But if you need to meet your targeted demand, you need to have additional 2 operators onto our station of combiner here as well, which will reduce the cycle time from 3 to 1.5. And then the operator from here will be shared with this for the extra 0.5 minutes, okay, which is going to make the cycle time for the particular time station to 2 minutes. So that is what we have found out, that if our cycle time is more than 2 minutes into the system, we are not going to meet our targeted demand. So the takt for the line needs to be under 2 minutes per bottle, right? So that is the finding for these 2 days, simulation case study. So we are able to debottleneck the systems. Now, if you could look at, we are going to have what? We are going to have ST3 and ST2 as a real bottleneck stations, which are back to back. Okay. And then if you could look at the STC1 is blocked, and that is basically this. And then we have ST1, which is blocked. That means that the buffer is not required here. So let us do one thing now. We are basically going to show connections, and we are going to remove the buffer from here. Okay, let us connect it directly. We need buffer here, right? So let us add a buffer here because it is blocked here, right? And we also need another buffer which is after the caps, which needs to be placed here. Okay, so and then the combiner, let us change the ports from this to this. Now when I reset and run, you can see that my system is still blocked to the 50%. Now what I can do is I can increase the buffer to say 10 parts. Okay, and here as well I'll make it 10 parts. And when I just reset and run this, what you're going to see? Okay, So this buffer is not much impacting our throughput because the bottleneck things are these two stations, and these two stations are then controlling our combinations as well. So putting a buffer, okay, is not majorly impacting our throughput. So for example, if I just make this 100, and if I make this 100, and if I just reset this and run this, what you're going to get just a 7% improvement in the utilization, but it's not advisable to have this much WIP as it is going to increase our inventory cost. So let us have this 2, okay, and let us see what happens. So it's 50%. If I make this 1, still it's going to be 50% with the blockages of the stuff. So let us have one WIP here, and that is sufficient for the system to run. And here is what we are going to get a throughput of 33 pallets per day. So this is the end of the case study, guys, the Flexsim problem statement which we worked on to, with all details which we can make into the simulation model. A detailed explanation I've tried to bring it out to you. So we had part 1 in that 2 parts, part 2 in that 2 parts, and part 3 in which we are going to have 2 parts. So this is a pure combo of one of the problem statement on understanding bottlenecks into the system. Okay, so this is about random industries. It is a random industry we have taken to analyze a system so that you can, create a simulation model based on the problem statement you're going to get in. Then you're going to learn bringing the graphs into the state as per your analysis required. Then we learned about, how to analyze or study the graphs, which types of graphs should be used. Then we identified the buffer requirements. Then we identified how we can debottleneck the systems. Okay, we find it out, that tracked into the system, and we applied the brakes for the systems, and we did a lot of steps by referring to this single problem statement. I hope you would have liked this tutorial on understanding Flexsim modeling using a problem statement. We will be bringing out a next video using our next new problem statement, analyzing another problem in a manufacturing industry. So till then, stay tuned, keep watching, keep visiting our website Leansimcorp.com for exciting educational content. Let us know if anything needs to be improved in the comment section, and we will meet in another interesting video on Leansimcorp channel. Thanks for watching. Bye bye.